we're going to consider the series, the summation from 2 to infinity of 1 divided by n times the natural log of n. We want to know if this series converges or diverges. So first we'll try using the test for divergence, taking the limit as n goes to infinity of 1 divided by n times natural log of n gives us 0. And 0 means the test for divergence is inconclusive. So we have to try something else. So next thing we'll try is the integral test. Now this is a positive term series. Every term of the series is positive because the lowest value of n we can plug in is 2. Natural log of 2 is positive, natural log of 3 is positive, and so on. So every term is positive. Now we need a function that will give us the nth term of our series when we plug in a positive integer n greater than or equal to 2. Well, clearly the only such function is f of x equals 1 divided by x times natural log of x. And we are considering this function for x in the interval 2 to infinity, and that's because the series starts at 2. Now to use the integral test we must verify 4 conditions that this function must satisfy. The first condition is that the function must be continuous on the interval 2 to infinity. When we look at this function we see that first it's only defined for positive values of x, and it is undefined at 1 because 1 will make the denominator 0, and it's defined and continuous at every other value of x. Since 1 is not in this interval, we conclude that the function is continuous on this interval. The second condition, we need to check that this function is positive on this interval. Once again, we look at this function. Natural log of 2 is positive. Clearly x evaluated at 2 is positive, and similarly for anything greater than 2, natural log will be positive, x will be positive, the denominator will be positive, 1 over positive numbers will be positive. So this is true as well. The third condition is that f is decreasing on the interval 2 to infinity. We can take the derivative and show that the derivative is negative for any value of x in the interval, but we don't need to do that. The numerator is 1, and as x becomes bigger and bigger and bigger, so does x times natural log of x, and therefore 1 divided by x times natural log of x gets smaller and smaller and smaller. So this function is decreasing on the interval. And then condition 4 is already met because if we plug in n into the function where n represents a positive integer greater than or equal to 2, we get the nth term of our series 1 divided by n times the natural log of n. So this is true for n equals to 2 or 3 or 4 or 5 or 6 and so on. So because these 4 conditions are met, we can now conclude the following. Our series n equals 2 to infinity of 1 divided by n times natural log of n, and the improper integral from 2 to infinity 1 divided by x times natural log of x, either both converge or both diverge. So what that means is that if the integral diverges, so does the series, and if the integral converges, so does the series. But if they do converge, they don't converge to the same limit. So let's look at this integral. First we'll find antiderivative of 1 divided by x times natural log of x. We'll do that by u substitution. U will be natural log of x. Du is 1 over x dx. So this becomes the integral of 1 over u du, which is natural log of absolute value of u. So that means that the antiderivative, n antiderivative with constant 0 of 1 divided by x ln of x is equal to natural log of absolute value of natural log of x. Now, because we're working on the interval from 2 to infinity, natural log is positive for any value of x in that interval. We can drop absolute value and write it as natural log of x. So now returning to the improper integral, we have integral from 2 to infinity 1 divided by x natural log of x is equal to natural log of x evaluated at from 2 to infinity. And this is the limit as x goes to infinity of natural log of x minus natural log of 2. Now let's take a look at that limit. As x becomes larger and larger and larger, natural log of x grows without bound, and then applying another natural log to larger and larger numbers is not going to be going to a finite number. So this is heading toward infinity, and we can conclude that the integral from 2 to infinity 1 divided by x times the natural log of x diverges. And that means so does the series, the summation n equals 2 to infinity of 1 divided by n times natural log of n. And this is by the integral test. And that's the conclusion. The series diverges. For more videos, visit www.mathprepvideos.com.